So this is a 2381 paper, Unit 2, Stage 1, November 2008. Again, with the last video, all MathsWatch clips are written on in pink, so from the images or from the video, please have a look at the corresponding MathsWatch clips if you're still not sure. So, question 1. Seamus travelled 120 miles in 3 hours. What was his average speed in miles per hour? And you really need to learn your speed distance time triangle for this. If you don't know it, you can break down the units in miles per hour. You know, speed is distance, because miles is in distance is in miles, hour is time. So you know speed is distance divided by time, which will allow you to put it into that triangle. So what is this average speed in miles per hour? Cover-up speed is distance divided by time. So our distance is 120, our time is 3 hours. Let's check the units, miles per hour, so I'm happy to put my time in hours. So 120 divided by 3, well what's 12 divided by 3? It's 4, so it's going to be 40. So 40 miles per hour. Next, what is the area of this triangle? So triangle is base times height divided by 2. Some of you might like to remember it as a half times base times height, both the same thing. So base times height, 10 times 6 is 60, and then half is going to be 30. Double check our units, centimetres squared. Question 3, which is the best estimate? Now if this is estimate, we need to round everything to one significant figure. So this is going to give us 40 times 50 divided by 2 plus 3. So let's simplify. 4 times 5 is 20, so 40 times 50 is 2000. 2 plus 3 is 5. Now the trick of doing divide by 5 is divide by 10 and then double it. So we can do that really easily here. So divide by 10, that takes it down to 200, and then double it takes back up to 400. So really nice easy trick for dividing by 5. Okay, question 4. Sweets cost 5 pence each. Shamonti buys X amount of sweets. So what is the expression in terms of X for the total cost? Well, if each sweet costs 5 pence, then it doesn't make any sense for us to just have X. It doesn't make any sense for a lot of these. What we need to do is, for each sweet is costing 5 pence, so 5 times X is going to give us our answer. For question 5, what is this written in simplest form? Let's collect like terms. So we've got 2a plus 3a is going to give me 5a. And then we've got 5b minus 2b is going to give me 3b. Don't get confused with your signs. 2 take away 5 is 3, not negative 3. So 5a plus 3b is this one here. Okay, next question. What is the lowest common multiple of 20 and 35? The easiest way to do this is to count up in the multiples of both numbers and find where they first have one in common. So we've got 20, 40, 60, 80, 100. Don't know whether I need to keep going for now. Let's check 35, see if we need to keep going. Count up in 35. 35, 70, 105. Plus 35 is 140. Let's keep this one going. 120, 140. So 140 is going to be my lowest common multiple, which is this one here. Given that 4.5 times 5.5 is 24.75, what is the value of this? Now the way I would do this is, what has happened to this number here? This number has got 10 times smaller, so our final answer would expect to be 10 times smaller. This one, so this one would expect 10 times smaller. This number here, though, has got how many times bigger? Got 100 times bigger. Okay, so we'd expect the answer to end up as 100 times bigger. Well, if that's 10 times smaller but we want 100 times bigger, we're actually only going to end up with 10 times bigger. So our answer to this calculation is going to be 10 times bigger than this one. So we're looking for 247.5. Okay, factorizing. So this is, we can look at these two things here and we can say, what have we got in both terms? So factorize, we can take an x out of both, which leaves me with x minus 4. If we expand it just to check, x times x is x squared, x times minus 4 is minus 4x. So we've got x minus 4. Okay, next, question 9. For this method, use whatever method you like. You can use FOIL, so first, outside, inside, last. You can use your window and peanut method, it is your choice. So if we do it this way, we've got x and 3, x and 4. So x times x is x squared, x times 3 is 3x, x times 4 is 4x, 3 times 4 is 12. Then with this method, simplify what's in your peanut. So we've got x squared plus 7x plus 12, which is going to be this one. Okay, so next question. Here are the first 5 terms in an arithmetic sequence. So what do? I say, what am I counting up in? So I've added on 7, I've added on 7, I've added on 7. So I'm going to write down 7. It's an nth term question, so I'm going to write down an n. And I say to myself, what goes here? So using that same pattern of adding on 7 each time, what would be here? It would actually have been a minus 5. So in the end, I put my minus 5. So I'm looking for 7n minus 5, which is here. Okay, next question. The cuboid is drawn on a 3D grid. Point Q has coordinates 3, 1 and 2, so that's my x, y and z coordinates. The coordinates of P are what? So what I need to do here, I'm going to talk you through each coordinate and we see if it's different or see if it's the same as Q. So for P here, this x coordinate is how far along it is here. So you can see that Q is the same distance along the x-axis as P is. So our first number is going to be 3. We're now looking at the y. P and Q, they're both at the same height above the x-axis. So you know that y coordinate is also going to be the same. And then that z coordinate, that is now different. Okay, Q is out at 2. P is back at 0. It's on the x-axis. So if we think about that, we're back at 0. So we're going to have a 0 on the end. So we're looking for 3, 1, 0. Okay, next question. R is the point with coordinates 4, 1. S is the point with coordinates 6, 5. What are the coordinates of the midpoint? Now, as I said in the last video, there are 2 different ways to do this. Some of you might like the number line method. So if you've got 4, 5, and 6, what's halfway between 4 and 6? Well, it's 5. You might not need to do a number line. You could just do it in your head. Or if the numbers aren't so nice, you can just work at the average. 4 and 6 is 10. Half it is 2. No, it's not. It's 5. Half of 10 is 5. So we know that x coordinate is going to be 5. Our y coordinate, let's use the average method this time. 5 plus 1 is 6. Half it is 3. But again, you could have drawn yourself a number line and worked out what's halfway between 1 and 5. So we're looking for 5, 3. Okay, question 13. 2 and then 3x plus 4. So 2 times 3x is going to give me 6x. 2 times 4 is going to give me 8. So I'm looking for 6x plus 8, which is on the end here. What is this as an ordinary number? Now what I'll do here is I'll write out my 2.31 and I need to times it. Two ways of thinking about this. You want to move the decimal point 4 times, but actually I'm timesing it by 10,000. So I'm going to have 1, 2, 3, 4. There's my new decimal point, and I'm going to fill in my zeros. So don't forget, what we're technically doing is timesing by 10,000, but I can also think about that as moving my decimal point 4 times. If that was a minus number, our number would get really small. Because it's not a minus number, it's a positive number, we're going to end up with a large number. So 23100. 23100 is here.